Okay, it's actually going to let me do it now. All right, cool. All right, so you hanging with me here, Space Marine. Inside of here, we got some basic introduction, page 1 to measurement and probability theory. We're going to change this, Space Marine. Wait, we with me, MTF? Okay, so I'm actually going to work this out a little bit, and we'll do some definitions. Most of this is done. Find an example, throw it in the box, get ready for lowercase form of delta here, because this will be kind of important, but we're going to start this from the delta's perspective first. We got 18-year-olds, not 0 to 18 in terms of a lowercase form of delta additive measure. It's like throwing in a kid into the mix, not a delta. And I don't like the way that started, and I actually changed it off. Measurement, theory, and probability context. 1. Demolition and construction of measure, right? Of measures. So, like you'd be talking to this, we're going to go through the prefix, the key here, all the information. We're going to introduction at this point in time, introduction and examples. Comes after that. We're kind of demoing that creation, destruction, real close to each other before we get to introductions and examples. I know it's weird. I actually kind of screwed that up, but reading it out like that kind of gives you some context to this measure. I would see that distance A to B when we get into the math here in a second works. I actually changed this to capital form of delta. Why? Because add a capital form of delta. This will make sense when we get to measurable sets, and instead of this being rings and systems, I actually put that to a algebra or delta algebra. It's like when the additive measure is a delta, that's the result you will get measurable. That this is not the any kid in this world that you throw into it, but it'll become that in a group set of, where is here, lowercase form of finite measurements. All we have is this group of students, this group of deltas, and I got to figure out which one of them is doing certain soft operations inside of there as measures, crypto stuff. Uh, and we actually cut some of this out. So it's introduction and examples, delta additive measures, delta subtractive measures, because we're trying to keep this balance. That if I pull out one of your deltas, what does that subtraction measurement do? Can you prepare for that? Do you understand why that measurement and probability is going to affect that way? That theoretically, heaven forbid, something happened to them. That's why we don't go down those roads. That's why we don't do it. And if we do, we use this scientific mathematical process for it. And then you get the lowercase form of delta additive measures. So again, that we can add kids to this, that it's a school system for kids, not full-on adults, because the range of the spectrum says 0 to 18 is not 18 to 36 fully developed, but sometimes you catch 17-year-old, 16-year-old, it's that. So you call them a lowercase form of delta until you go through the other measurements. We do this to make sure that this set, measurable set, is something later on about infinite or finite measurements to null sets. In the school, it nullifies that out. You put that in there as a measurement tool, as a measure, to reduce the probability in there of putting that rabbit somewhere where it's not supposed to be, or putting it on that bunny box where it's not supposed to be. Really all you need is these top 10. Cut out this thing, just make it delta measurement. So introduction, delta, additive measure, delta, subtractive measure, lowercase form of delta, and just because I'm fundamental, lowercase form of delta, subtractive, examples, and using probability theory. So now that we just gave you a bunch of examples, delta form of additive measures, delta form of that, we're going to recreate this, and that's kind of the nature of wanting to get to that bottom spot of these finite measures or measurable sets. These are institutional right hand rule, the sets that we use for systematic differences. When we have that, we can systematically go through the results and deal with it. And so we'll come down here to the actual introduction. And don't you hate this hot garbage mess for what it is? It's like, oh, I know what that one is. That's a real number. Yeah, but it's broken as far as being in here like this, because what does it truly define? I mean, there you have the lower form of delta or epsilon up there for what it does, and inside of here, then you just gave them a real number. That's, a kid between 18 and 36, which individually in social contagion works great for a rational number, but it doesn't hold up. So you have to give that definition inside here that this is a real number, that this is 7, 12, 14, 1. You can't have none. 0 is not a rational number. You can't have none of something. I know, right? It's weird, but I didn't have, plenty of times I didn't have any when I needed something, but that's what makes it irrational, not rational. We don't have a delta. We don't have that state in there yet because we haven't built it yet in the introduction. We're just taking granted for it and using some kinetic momentum, and we don't even know what any of those symbols mean. So keep reading this through. The main subject of this lecture course of the notion of measure, MAB, MA, but the beta radiation version of that is classrooms and students. If FMA, the effect of that wave in a classroom, JP talking about look at one student, you're talking to all of them. The rigorous definition of measure will be given later. All right, fine, sure, whatever. But now we can recall the families from the elementary mathematical notation, which is, again, just some fluffery inside of here as far as what you're doing, which are all particular cases of measure. 1. Length of an interval in rational. So what are we talking about? We are talking about AB. If I, the irrational number, I, rational, irrational, is a bounded interval with an endpoint A to B, being a delta, you're going to say, well, for sure in a measurable set, you can't really do that until you're 18, and then it takes a T90 day, and after that point in time, I could tell you that is A and that is B. That's a 90-day thing. It is day 1 to day 90. It is day 5, kind of. It can be day 5. Orientation, introduction, that zeroes it out. That is now A, 1 to whatever variable, and we just set all those measurements and stuff out for you. And these will be lots of case studies, examples in psychology of delta being added to a situation or one being pulled out or a null state. When we didn't have that, we could kind of idealize it from Alice and Bob's perspective. That is A, that is the distance B in the length of an irrational number, right? So any number, 5 days, 10, a 90-day, we're doing a 6-week thing or whatever, it's irrational, or it's rational in the fact that there are real numbers to that. We can set that measurement, but it is irrational. Okay, two sides of the coin. That is, I is one of the intervals, parentheses A and B, bracket A and B, half bracket, which means it's part of the equation inside of here. You would say it's contained inside of it, but here on the back end, not only is it here, that we can start that equation and end it in two different fields. A bracket and a parentheses means that both of them mean do this multiple first. Figure out the length of the T90 course that you really need, and you do that by probability and measurements, right? Because then if we got a different obstacle run that in a measurable set that we said was a better result in one of the cargo containers, that we have 5 military bases, all AR backyard to the obstacle course, which is the same obstacle course, and then the only thing we changed was the timelines that we did this, and we found out that it mechanically got them to do something, whatever A and B is here, to that result. That inside of there, it would be quantified inside that parentheses. Do that first. Then we'll break that down into a bracket, which is, can we recreate that mechanism in some way, which is why this is hot garbage for the most part without real examples right here. It's kind of tit for tat, right? 0, Big Bang system started, repellent tower, and that was the irrational number that defined our lengths, and you kind of have to walk that dog out right while you're doing it, not after all this nonsense of doing all this and being like, well, the Alice and Bob example we're dealing with here, that's bullshit. I don't put up with it. I'm a student, I pay you money, you go to a logo company or something like that, I want to know what's going on with my $1,800 because I could pay 10 kids $18 an hour for 1 hour, and I should be able to get 1,000 1,000 or 100, yeah, 1,000 different drawings for a logo design. What am I paying for here? You just trying to clean me out, you asshole? What am I really getting out of this? Did you do this to any of the businesses in town to make sure that the kids had the proper examples of lowercase form of delta? Delta. Be clear. Like a close present danger. Cheeseburger factory right here. Now that length is an irrational number in the bracket of a McDonald's cheeseburger. We're going to subtract B from all the alphas inside of there, or in this case the lower form of alpha is probably not president, but one of McDonald's fucking gremlins he's got running over there. We'll leave them behind. The useful properties of length is additive. If the intervals, not always, but right hand rule, you want deltas to come in and lead a positive result. You want a lowercase form, a kid, to come in and actually be beneficial to the company and useful. Or useful and interesting to that company, that it serves the purpose as a kid growing up through the process where this irrational length stuff all plays out and all works, but in the way it's still not delta unit over there, which should probability in a set probability in a measurable set that we got in front of this. We have 1 plus stuff to it. It's not just that we're granting that with that system. If you go to McDonald's and learn how to become a delta, which you can, it's still not going to come up to the training of probability if I take them from Delta Camp and send them over there comparatively to what you know, which MIB, Will Smith there, you ran down that thing on foot. Business economics, sociology, people as group theory and set theory there, that, yeah, you can put a big one down. Anyway, let's keep going here. I don't know how much longer I got here, but I is disjointed union. All right, the useful properties of a length and additive if interval I is disjoined union of the finite family, which then you didn't even give them this symbol. You didn't give them R. You didn't give them an example of what this will be for us. Here, a time clock, which is right-hand rule, but you got to kind of specify, especially at the elementary level. That is part of the teacher's test. It comes up on board. That's a point. And inside here, then you didn't give what this example was. You never gave them what the value of K is in this set or measurement. You just let them out into the world and let the space in. You have no clue what this symbol is. Now I got to go hunt that down in terms of the measurement where A and B are supposed to be well defined, and you gave me nothing. Kind of pisses you off. All right, but if you manage to pound through that in the family, again, a bracket I, K to the Ingling's angle of K, that this set is an n number and k equals 1. That's the McDonald's in numbers with u working in it, because that's the nucleus n and p by any different standard in there. N and p, that length, the rational 7, equals number sigma k equals 1. That I'm holding that to the power, that log 2, 10, 5, it'll work in there. If you try any other log number by that standard in that power or in that position, that it wouldn't work. Now, what's stopping anybody to say that any interval could be used as that model? Well, it's still a McDonald's. It makes cheeseburgers, it sells fries, it consistently sells roughly that many fries, so week after week or month after month, whatever it takes the truck, 36,000 pounds worth of McDonald's shit in there. And different combinations and organizations would give you the n numbers in that sigma environment relative to temperature 1. It's additive to the system tomorrow, but it's zeroed out in a length of a irrational kinetic position, I guess, and so without putting that information there, that's really what we're doing, then the next time you'll do it. But mathematicians are catty like that, like, oh, okay, wasn't that what it was? And they never bothered to define whether which teaching model, and especially lower form of delta, was good. So I want you to take those notes and you run this down, because this should be a stone mill. Feel me, functions, dominion? All right, catch you on the next one.